deference to you speakers. It's been really wonderful to see. I mean, there actually are a lot of people from the fusion industry RSVP'd, from private fusion industry, startups to big organizations such as the one that Joelle, Christina, Maria, Livia, Laura, as all of you guys represent. So it's really quite exciting to see the turnout to come and listen to you guys present, kind of show a human side to fusion. With that said, I'm going to go ahead and stop sharing this screen, and there we go. And go back to Zoom. Okay. All right. Okay, great. At 5 after, so it's time to get started. I am humbled and grateful to have this opportunity to be the moderator for such an esteemed panel of women scientists, professional women in the fusion industry. You all have such amazing stories. You are just such admirable contributors to the future of our planet. I mean, you are quite literally the holders of the beacons of light. So as I said, I'm humbled and very grateful for this opportunity, especially too, I want to say thanks to the U.S. Fusion Energy team who allowed for this panel to take place, and who are the organizers of Fusion Energy Week. So thank you so much to them, and for letting us do this. This is the structure. I'm going to take just a couple of minutes to quickly say the names and the affiliations of each speaker, and then it will be up to each speaker to present. They'll have about 5 to 7 minutes of presenting what they do, who they are, how they came to be, who and what they're doing, and then we will have a Q&A. So if you are if you're one of the guests, please feel free to raise your hand during Q&A, or also put your question in the chat, and we will try to get to it. All right, let me start with Joelle Elbez-Uzan. She is the head of the Department of Innovation at Demo Fusion, which is part of EUROfusion. So it's really one of the major players, not just in Europe, but in the world. She's also formerly at ITER, of course, down in Kardash. And so she was actually the head of division of nuclear safety. So she's got quite a lot of experience working with nuclear regulators, and I'm sure she'll talk a little bit about that. Then we have we also have the esteemed Christina Rea, who has been a pioneer in AI research and fusion energy for years now. So she's the principal research scientist and group leader at MIT Plasma Science and Fusion Center at the Massachusetts Institute of Technology. We have Laura Zhang, who is a plasma physicist and also a team lead at Tokamak Energy, which is UK based and really one of the leading companies in private companies in fusion industry and fusion energy. So can't wait to hear more about what's going on there and what she's doing with her team. She also has 6 years at the Princeton Plasma Physics Laboratory. So we have Livia Casali, who is an assistant professor at the University of Tennessee Zinkle faculty fellow. She's also a Department of Energy Early Career Awardee, and she's an ITER research scientist fellow. And if you look at her LinkedIn profile, you'll see her shaking hands at the United States Senate and Capitol with a bunch of policymakers just in the last couple of weeks. So, and then we have María Ortiz de Zuniga López-Chicheri, And she is head of project engineering at Fusion for Energy. So another major powerhouse of European fusion, but also, you know, in the world as well. So ladies, you have, you are just such role models. I can't wait to hear from each of you. We have the lineup is Joelle is starting, and then Cristina next. And then if we've forgotten the, you know, we can just go from there. But Joelle first, and then Cristina next. And I am muting now, so please take it away.
All right, thank you, Paige, very much. Good morning, good afternoon, good evening to everyone. Thank you to be here with us today. So I will introduce myself briefly related to my experience. So first of all, I am an engineer, and I have also a PhD, and I start my career in nuclear since the beginning, actually, and at the early stage of my career, I was working on a fission installation, and in particular in design engineering and safety engineering of fission reactors. So I got the opportunity to, I would say, develop, study into the detail this kind of installations, and to be able also to develop the design activity. Then when France has decided to welcome ITER at Cadarache, I've been asked by the CEA to prepare the first safety file, which aimed to demonstrate that ITER can be licensed in France. And it was in 2000. So at that moment, the main question that we wanted to address was to show or not that a fusion machine can be licensed in France, considering the fact that the regulation was writing for fission installation. And at that moment, we have identified every, I would say, area in a regulation that could be adapted to fusion specificity. So there was a lot of interaction with the regulator, as you said. And very quickly, we have been somewhere obliged to review the design of ITER, because finally, ITER has been designed on a virtual site, but the safety requirement and all these engineering-related matter in terms of integration, for instance, were not considered at a very, I would say, first stage of a conceptual design of ITER. So it was a long work, and then when the Cadarache site has been selected to welcome ITER, to implement ITER, then I have been hired by ITER organization to lead licensing process, to lead the nuclear safety activities, as well as all the interfaces with the public. So in order to explain to the public what are the specificity of such a fusion machine in terms of physics, in terms of engineering, in terms of nuclear safety, in terms of environmental impact. I stayed there during 14 years. And what I would underline, independently of the design, which was quite tricky to raise ITER machine as a level of a nuclear machine, regarding the fact that there are 4 kilograms of tritium in this machine. It's a certain, I would say, significant quantity of tritium. The most difficult, in my view, there were two aspects. The first one is related to the flow down of the safety requirement. It's something that you implement the safety requirements into the design, but the most difficult is to implement them during the fabrication and during the assembly. So that is also, it was a challenge. It was a first of kind. So we were discovering everything, and this aspect was very interesting. And the second aspect that I would like to emphasize is the culture, the safety culture, and the project management culture. Because at that moment, most of the people who were joining this fantastic project, which is ITER, were physicists, not, I would say, used to develop projects and to develop engineering methods. So that is not to criticize at all, but it was the fact. And we grow up all together to a point where finally we were surrounding with very skilled person in a lot of domains, including safety culture and engineering culture. And finally, I think one of the most important time in my career was obviously when we got the license of ITER, so to authorize the construction of the first nuclear installation in the world for fusion. So that it was a really historical day. There is a movie, by the way, when the French regulator, at the end of after a long process, told us, informed us in person, because it was at the end of a committee, there was a lot of committee discussion with the expert of the regulator, that ITER can be licensed in France, and then we can start the construction. And in particular, I would like to emphasize one point. This license was given to us, to ITER organization, by the committee in France who deals with all the fission installation. And they got a very fission mind, you know, they were only minded for fission installation. And I think one of the most challenging aspects to get the license was to convince them that we cannot apply the fission requirement to fusion, and that we have to adapt to the specificity regarding several aspects that I will not develop too much now, but maybe if there is any question afterward. And since 22, I moved to EUROfusion, where I am managing the department for innovation, engineering, technology, to prepare the next stage, to prepare the pilot power plant for fusion, and to try to accelerate all of the technological gaps that we can face, in particular by developing some innovative technology that will allow us to definitively fulfill and accelerate the development of this energy in the world. And I am also working on licensing for this kind of machine. And I think that, as I was saying to Paige when before that we start the meeting, I am surrounded only by fantastic people, very motivated, very talented. And I think that we have the change in fusion community to have a lot of people very valuable, and that allow us to have a daily work very, very interesting. So for me, the human relationship is very important as well. And we can say that we are surrounded by very good people in that domain as well. That's it for me, Paige. I try to be synthetic.
That was wonderful. I love your emphasis on the human-centric part of the technology. I think that that's something that will come through with a lot of you women. But Christina's up, so please, I don't want to take any of the time.
Thank you, Paige. Tough act to follow, Joelle. It was extremely interesting and detailed. I'll try to give a brief introduction of who I am, how I got to be here. So next year will mark my 10th year kind of professionally in a career in fusion. So I started, but if I have to take some step backs, like in terms of, this was not really a straight line trajectory like to where I am. And so Basically, my focus during my university years were not really in fusion, but more like on the study of the nucleus and the complex nuclear interactions. I was like a theorist in nuclear reaction theory, always with a passion around, energy and energy generation and finding, sustainable source of energies. I was more interested in fission at the time. Though for a series of fortunate coincidences, I ended up pursuing then a PhD in Padua still in nuclear reaction theory. After a year or so of working on the project, I did feel like I was at a loss, kind of had an existential crisis, and I was like, oh my God, I either drop out of the field or I just do find, really something that I'm passionate about and motivated about. And so I stumbled upon a seminar from Professor Piero Martin, who actually I'm hosting today here at the PSLC. And he, at the time back in Italy, he was explaining, kind of the basis of fusion, the promise of fusion, and how the community was working since already the 1950s and even before to address, the knowledge bases that can solidify both, an integrated solution from the physics and engineering standpoint that can get us to, to either to demo and to the next solutions of that bring us fusion energy on the grid. So I got passionate about the topic, and I was lucky enough that I could switch kind of subjects during, while I was running after this PhD. I started working on fusion topics around the area actually of transport and magnetic topology at the edge on an experiment that we still have in Padua at the University of Padua, which is a reverse field pinch, is a different configuration than the mainstream Tokamak, which is at the basis of ITER at the moment. And so I worked there. And I became really enthusiastic about it, pursuing, this goal of designing solutions for clean energy production, fusing nuclei together, trying to reproduce the same reactions that power the stars. And also, like, what motivated me was really the challenge of unsolved problems. So while nuclear reaction theory felt so dry as a field, because kind of, we solved that already, and we were just refining models to find, better, whatever optical potentials that can map interactions between nuclear particles. And I was like, oh, that's so boring. But instead, fusion provided, a full field of challenges that were still open to be addressed and open to solutions. So that's what was motivational for me. I ended my PhD in Padua back in 2015, kind of, 10 years ago now. At the time, unfortunately, there was lack of funding, and so I was not really ready to pack my luggage and leave the country. And so I stayed around, and I had a brief detour away from fusion into the private sector, and I worked as a data scientist for a bank, one of the biggest banks in Europe. And I worked side to side next to PhD in statistics. I learned a lot on the job, and that's where I reskilled myself more into machine learning and artificial intelligence techniques. After a year or so, again, another existential crisis. They tend to happen recurrently in my life, I guess. And that's, and actually through my partner at the time, my ex-boyfriend, current spouse, we ended up deciding to, continue and pursue the academic opportunities in fusion. And that's when, we decided to basically ship ourselves over to California to pursue a postdoc there. And I was able to find a postdoc at MIT to work in the D3D National Fusion Facility hosted by General Atomics in San Diego. Fun fact, that's where Livia and I met. And so since 2016, I've been with MIT, starting my career as a postdoc in fusion, and then progressing towards, research scientist and group leader, and now principal research scientist. Right now, I have a group of 18, 19 people, not counting like collaborators and undergrads that come and go. They are great, so fun to work with. I directly advise and mentor 5 PhD students, 4 postdocs, a couple of research scientists. The team spans many different fields on disruption prevention, which is actually a different field than my grad school topic. So that was also fun to learn. And disruptions are kind of one of the showstopper that are still, they still need to be solved and addressed in fusion to get to a steady state solution for a burning plasma regime that can work and that can allow us to put, energy on the grid. So my team is operating on different aspects of the problem, like looking at different strategies for prevention, mitigation of disruptions, or prediction of disruptions by embedding advanced statistical solutions and artificial intelligence and machine learning models. So I was able to reuse that gap year that I took away from the field and build upon it. And I'm pretty committed at maintaining that kind of diversified skill set in my group. And so we really look at the problem from an interpretable physics-driven perspective, but we are trying to combine it with solutions that do embed advanced statistical modeling and AI machine learning techniques. But in order to, really advance our own understanding and come up with solutions that can really advance the field and get us to burning plasma soon. So. Yeah, that's kind of a summary of who am I and why I'm here.
That's wonderful, Christina. Thank you so much for your candor. I think it would seem like you have to have a lot of courage in any field, but especially in science and especially in fusion, to really follow your path. So and thank you, because if there aren't a lot of people who can do your job, so a lot of gratitude for that. Looking forward to coming back around in the Q&A. I think Laura's up next. Laura, are you ready?
Hello, can you hear me? Yes, great. It's my IT setup is never guaranteed to work. So, I'm Laura. Nice to meet you all. My story is going to be much shorter. So, well, maybe not. So I'm currently living in the UK, so it's like getting a little late in the day. I actually was born and raised in China. I left China when I was 17 years old, and then I went to college on the west coast of America at this tiny little college that you might have heard of called Harvey Mudd College. And this is probably the longest part of the story of my career path, because during my college time, I didn't know that I was going to be a physicist. I was not one of those that knew I was needed to go into fusion energy since I was 5. I did not. I entered college as a biomedical engineering major. I was going to go to med school. And then somewhere during my sophomore year, a few existential crises later, I realized that it's not something that I wanted for myself, it's what my parents wanted out of me. So I rage quit the major and picked up computer science. Not physics, still computer science. So I was in that for like a little bit, about like a year-ish, until I realized, you know what, not that one, not that one either. At this point, my professor, my advisors were starting to get a little nervous because we're like at this point kind of going into my junior year of college and I still haven't really picked a major. And I said, okay, so this is the last time I'm going to pick and I'm going to decide on physics at this point. But at that point, it was still entirely because I just enjoy doing physics more. Really, it's because I enjoy doing the math associated with the physics more than the math in computer science. I still like computer science very much, so I ended up having like a minor, let's call it a minor-esque thing in computer science with my physics major. The entrance into plasma physics was entirely happenstance. It was because my junior summer, I didn't know what I was going to do for the summer, and this professor that I really like, who happened to be doing plasma physics, said he had a spot in his lab, and he's welcoming me to join his group if I would like. And that was entirely the reason, because that's the entire reason I went into plasma physics and fusion. So that basically sets the tone for the rest of the story. Is really just like, I never really had a clear goal that I'm working towards. It's just that every point where I came to a crossroad, and out of the many options, I chose the one that fit me the best at the time and pick the thing that will make me the happiest. So when the time to apply for grad school came, I realized, I did like plasma physics. I enjoy doing this. So I applied to plasma physics programs and I ended up in Princeton. And then I will tell you again for this audience, during my time at Princeton, at many, many points during my time at Princeton, I almost quit and did something else. I was still very tempted to go back to computer science at many instances. I took some time off and actually did a internship at Siemens Corporate Technology to do machine learning. And then decided, you know what, I still like plasma physics better. So I went back to grad school. Ended up finishing a degree. And then as I was wrapping up, I was again wondering, you know what, maybe I should go back to computer science. But this is when this guy that I used to date, who is now my husband again, got a postdoc offer in England. I was like, okay, maybe I'll give this plasma physics thing another try. And that is the story of how I ended up at Tokamak Energy. I started Tokamak Energy with, no expectations, but turned out to really like it. I really like the energy of the people and just fitting with the group very well. We have a big experiment week coming up next week. So I ended up, being someone trained in theory and modeling, started doing more experimental work, which I really love. And after, short 2 years-ish at Tokamak Energy, I became a group leader and now have a little bit of a program of my own. So yeah, that is me across many continents, a very curved path. I don't know how long I will stick with this, but it's just what makes sense for me at the moment and me and my family.
That's awesome, Laura. That's so inspiring. It's so inspiring that you've just followed, your instincts as it's unfolded, and it's gotten you to such a wonderful and, I don't know, just like a real pivotal place in history. That's cool. Well, we'll come back. I'm sure there's questions bubbling up in people's minds. Let's jump over to Livia, and then Maria will follow.
Okay, so let's see, my story is a bit different. So I grew up in Rome, so I'm Italian, and I studied nuclear and subnuclear physics. Fun fact that I always tell, especially my students this day, I was actually a professional ballet dancer. That was all my life till I was in my 20s. I started when I was 3 years old. And I, did all the paths to, the ballet conservatory, and that's what I was doing, while eventually also studying, nuclear physics. I was training like 6 hours per day every day, and I had like a tremendous experience, which I think actually was very useful for my career in science right now, because as you can think, maybe the two things are disconnected. They're actually not. At that time, I learned so many important skills that are very useful for the career in science. Like, for instance, like perseverance, right? That you really need to work hard every day if you want to see results. The idea of team working, right? To be in a team that becomes really your family, because when you spend 6 hours per day with the rest of the ballet team, that's your family. You spend more time with them than with your actual family, and so on. So these were, I mean, I sometimes I feel this was like I was living another life compared to, the life I have today. And so there was a time where I was training 6 hours per day and studying nuclear physics. It became clear at that point that the two things couldn't really continue together. My group was going for a long tournée in Malaysia for 6 months. And really came down to what I'm going to do for, the rest of my life. And that time also coincides with, I was also feeling kind of be tired. So I decided to take a break, kind of a little bit forced break, let's say, at that point, but also coincide with the opportunity to go and do an Erasmus. I won an Erasmus fellowship to go to Germany, to this other university, and I practically finished my study there. This was in Freiburg, which is this lovely city in the west corner of Germany. where honestly I have spent probably the best year of my life. While being there, I was starting to actually, I fully commissioned a mass spectrometer that went to CERN. So I was supposed to go to CERN because that's what I was doing, was studying particle physics. But the case was that while I was there, I saw this advertisement for a summer university school in Garching, at IPP Garching, in plasma physics. And I was always very interested in, in the topic. And so I just applied. There were some fellowships they were giving to go there, and I just applied. And a few weeks later, I got this fellowship to go, and I was like, okay, I'm gonna go and learn about plasma physics. So I go to Munich, and there, I attend this course, which was really, life-changing for me. And I'm like, I want to do this. This is what I want to do. So I write my advisor, and I'm like, I'll finish to commission this mass spectrometer, but I'm not going to go to CERN. I really want to do this. I talked to some people there, there is a project I could work on in fusion. And so my advisor was very open-minded at the time. He said, I have no idea about fusion plasmas, but if that's what you want to do, and you can, support yourself, that you find, scholarship support and everything, I'll support you, whatever you do. And so that what happened. I got back. I found actually fellowships both from Germany and from Italy. And then I was able to move to Garching, where I did my master thesis. And then I actually stayed for my PhD at the Max Planck Institute, working on a really great machine, which is Asst upgrade. At that point, practically, so from Germany, which I love, and I had, really, really great time. I don't know, somehow it was clear to me that the cold weather and the gray sky wasn't really where I could see myself staying for a long time. So I decided to actually get this offer I had at General Atomics in California, San Diego. That's where, I actually arrived around the same time that Cristina arrived there. And so we actually had a very nice group with newer people that arrive more or less around at the same time. So there I started to work on completely different things. I was working before, and I started to work on both simulations and experiments on mostly focus on the edge of the plasma. Before I was working on the core of the plasma, then I started to work towards the edge of the plasma. So, it was a challenging transition, but it was very clear to me that there was a need for this field to grow. And so this is why I was getting more and more interested. And then eventually I started to actually connect what I knew before from the core of the plasma to the edge of the plasma. Then at a certain point, after I don't know how many years did we stay there, 5 years or so. I got this phone call to ask if I was interested in this position here at the University of Tennessee. And that was actually a funny part, because my husband and I just bought a house in San Diego. So I was like, well, I don't know. We are very interested right now in moving. It was in the middle of COVID, and, it was a difficult period for everybody. But anyway, cutting the story short, eventually we decided to actually take this opportunity, and we moved here to Tennessee. I have to admit, at that point, I was like, I'm not even sure where Tennessee is exactly. I know more or less where it is, but I never been in this part of the country, which, by the way, is actually really beautiful, very, very beautiful. So since then, I have been here, and the job I have right now is as crazy as wonderful at the same time, because I am just trying to juggle, many different things. So I teach. I created a new course in plasma physics. I also create, practically modify, but almost recreate a new course which deals with radiation and neutronics. that's something not that I was working on, but you know, it came as an opportunity, and so I took it. And then of course I still do a lot of research. I have a really vibrant group of PhD graduate students, some undergrad. I have now I'm also a postdoc, which I'm really happy to have welcome from France, and I have research, you know, around many different machines, both, you know, in Europe. So I D3D still here in San Diego as well as in Europe. And the nice part, I think, of this job is this connection that we have with our colleagues around the world, right? Like as we were first talking with Joelle, right? Like, you know, like met Marco or whoever, right? At Garching, and then you see them again at the conference, and it's just like a nice big family. We pretty much all know each other, and so this is the human aspect, I think, of working in fusion is particularly peculiar, I would say.
That is so fun. I love how you've been able to discover different parts of the whole world through your through following your journey and your path. That's so great. I can't wait to circle back in the Q&A time to kind of touch on some of these points. Maria, are you ready to grab the mic?
Yes, I am. Thank you very much. So yeah, I'm Maria. I'm Spanish, but I lived all my childhood abroad. So the rule my parents had is that we needed to go back to Spain to study university, and I come from a family where no one has ever done anything close to numbers, math, science, engineering, nothing at all. But that was what I was really good at. So when they asked me, what are you going to study? I just said, I don't know. And then I ended up saying, okay, I'll study computer engineering, just because I love doing math, you know. And I remember in summer, I would just take math books. Instead of reading, I would just do math exercises nonstop, like from one cover to the next, and next book, and next book, and next book. And so I thought, well, I don't know. I didn't even know what kind of engineering or what kind of science degrees there were in the world. I just went for the only one that I had heard of. So I went through my computer engineering degree. I studied in Spain and then also at University of Michigan 1 year. And then when I was at University of Michigan, I discovered like a whole new world. I was like, oh, this can really be really, really fun. I learned like a new way of thinking with that constructive criticism, you know, that I hadn't seen in Spain. So I thought, okay, maybe I'll move to the US, but I really wanted to go back to Europe. So I finished my computer engineering degree, which is like a mixture of computer science and electronics, basically, in Spain. And I was offered a job by one of my professors. He told me, well, you speak languages, and there's this project in Barcelona that wants an engineer with languages to develop their systems. So can you go for that interview? I was like, okay. So I remember that evening very clearly. I speak to my father, and he tells me, I know, I tell him, Dad, I'm going for an interview for something to like CERN in Barcelona. He's like, no, you're not going to CERN in Barcelona. You're going for the ITER domestic agency, the European domestic agency. I'm like, oh, really? Thank goodness I speak to you. Otherwise, I would think I'm going for one interview. Meanwhile, I'm going for another one. He's like, who told you about this? I'm like, well, this company who's planning to hire me. He's like, well, don't read about CERN because that's not where you're going. You're going to another one. So I read up about ITER and everything, and I think, wow, this is really, really cool. I mean, all I know is computer systems and programming and all these things. And they were sending me here basically because I'm still in Barcelona today to develop all their project management systems. So I come here, and one of these, like Livia was saying, one of these historical fusion Italian actually tells me, we're just starting the European agency for ITER at that time is what they were calling it here in Barcelona. So you could start subcontracted by your company, but we could quickly get you in here. I'm like, okay, let's go one step at a time. So I moved here. And then they offered me the job. I think it was 2 months after I was here, they offered me the job directly at Fusion for Energy, which at that time wasn't even called Fusion for Energy. It was just starting, basically. And when I started here, we were only 20 people. So, in fact, I had just got married, moved with my husband. He was very happy because he found a job here. It was all wonderful. And I started developing all their systems. ITER was also building up in Garage. So I started going to Garage, seeing what that was like. And through this role, it allowed me to have a very broad overview of the project, but without going into details. So over the course of many years, actually, I realized that I was missing a technical component to my work. You know, at the beginning, you get the challenge of, okay, this system and that system and this, and how do you interface everything, and trying to bring all these people together and making something useful for these people, you know, like planning, earn value, reporting, risk. But once you set up all these things and develop all the schedules, you're like, okay, and now it's like routine. So I started getting like a little bit hungry for more technical work. And it was just at that time that one of the large nuclear components was starting in terms of signing the contract and started manufacturing the vacuum vessel, which I called like my other child, because I've given so much time and effort to this component that it's almost like a child. But I realized that my background and my education was not really helping in that kind of task or role, right? So I went on and studied mechanical engineering. Then I realized that the neurons when you're 20 are nowhere close to neurons when you're 30 plus. And but I still went ahead because that's what I felt was more interesting. I needed that challenge, that mental challenge, right? And I started getting into the manufacturing of a nuclear component. I had always been, even though I was more on the system side, always been very keen on learning about welding, about materials, about nuclear safety, about everything. So I would follow every single course that I had the opportunity to follow. And so by the time I finished my mechanical engineering degree, I was appointed as a project manager for 3 of the 5 vacuum vessel sectors. And that was a really interesting experience because I had to manage a large number of factories around Europe. And I got to visit all of these sites. So each week I would go to a different one. And that was a wonderful learning and hands-on experience, you know, because then you get to see where the problems really are. And then after a maternity leave, I was offered to take another position, which was now in one of the heating systems for ITER, the deputy program manager for the electron cyclotron heating system, basically. And that was very different because it was a project that was no longer in manufacturing, but instead in design. So like a step back. But I could see how all my manufacturing experience was helping me prepare everything in advance, which I hadn't had the chance to do when I got into the vacuum vessel, because when I got into the vacuum vessel, everything was already in manufacturing, right? So that was a wonderful experience. And there you see how over the course of many years, your experience becomes useful to contribute to do things better, right? And to prepare things better. And but then when I took this job, the vacuum vessel had gone into some difficulties, basically. I mean, the vacuum vessel always had difficulties because it was the first of a kind, but it had gone into difficulties because we were trying to do a very specific kind of welding for a very specific material, with had to be under certain conditions, and it was a nuclear component, right? So one of our technical panel said, well, you've tried everything and nothing really helps you in terms of mathematical approach, like statistics and everything you could do. Why don't you try AI? And I think at that time, I was the only person who could have an idea of AI and who knew what the vacuum vessel was about. So they told me, well, Maria, you're no longer working on the vacuum vessel, but could you take care of this? So basically I thought, oh, this is amazing, because at the same time I had finished my mechanical engineering degree, and two professors of mine contacted me to actually apply AI on the vacuum vessel. So from the university side, they asked me this, and to do a PhD out of that. And from F4E side, so from Fusion for Energy side, they asked me the same. And this was within 1 week of each other. And I thought, this is not possible. But this is like my dream come true, because when I finished computer engineering, I remember going around the job fair and going to different stands and saying, I want to do AI. Do you do any AI? And they would tell me, no, there's no AI in Europe not right now. You need to go either to Switzerland or to the US. I thought, well, I've already lived in the US. I want to live in Europe now. So I kept my AI dream there on the side. And then 20 years later, suddenly they asked me, can you do AI on the vacuum vessel? And I thought, well, these two fields that have nothing to do. And I always thought studying computer engineering was like a mistake, because basically I never really worked in that field completely like all my other colleagues did. Suddenly they come together, and it's like a very useful added value to the organization. I was like, wow. And so I took on that task, and I started a PhD. And a lot of years later, which means neurons to study actually get worse there again. But it was very interesting, because it's you when you study later in life, you no longer do it for the grade or to pass an exam. You actually just want to learn and to get all that knowledge, and you think more. You almost take a more of a philosophical approach to life, rather than just passing and getting milestones done, right, or hitting those milestones. But at the same time, we had a very unfortunate event in the team that I was working as deputy program manager. We had a suicide of one of our colleagues. And so that just, I was there put as acting program manager, but that just really made me think about what the work environment was like, and why we were working, right? And I went from thinking very in a technically driven way and objective, and just reaching those milestones and doing all these things, to thinking, okay, we need to, and Joelle would probably tell me I'm wrong, but in my mind, I went from nuclear safety first to people first, And so then I spent a couple of years just developing the AI strategy on the engineering side, but always thinking that I could. It's almost like you feel like you can contribute to that environment and making that environment better, right? And you go through that experience because you feel like you need to make sure that if someone is in need, you're there to help them. And I guess it was that change in my approach that led me to my current position. I was offered to take up the um, quite a large unit that we have now at Fusion for Energy called Project Engineering, CAD, and Technical Data Management. There are 35 staff and 25 external service providers. And the good thing is that I've been asked to keep AI in my unit. So that is really nice for me, because I get to take care of all these people, in the sense that I give them the right tools and environment to be able to do their work, right, and to follow up and design and follow up all these contracts, right. But at the same time, I get to bring in those two fields or those two experiences, which I thought were never going to really complement each other and merge into something useful, and also train people. So train non-computer engineers, like train all the other engineers in thinking about AI opportunities and how AI can help them, and where we can be at the forefront in AI for engineering, the engineering side of fusion, right? So that's been very enriching for me.
You are all so amazingly inspiring. and you have shared so much of your hearts today. You know, a lot of candor, a lot of just, you know, the human journey of pursuing your, you know, your career path, and such a groundbreaking career path. You know, I really want to thank you all. We did have some questions lined up, but in respect to time, because you know, time is like the one thing that like you just really can't get more of. I was so tempted to actually ask all you ladies about AI. I don't know if you can see this on it's the Royal, where is it? Can you see it? The Royal, I don't think you can see it on the camera. It's not really coming through. But the Science in the Age of AI, how artificial intelligence is changing the nature and method of scientific research. And I can, I mean, all of you are in some kind of, you know, I mean, all of you are in the capacity of AI or innovation, you know, all the group team building and stuff. I'm trying to find the link to it. If I do, oh, here it is. Yeah. I'll drop the link in the chat. But now I think out of respect for time, let's just jump to the, anybody who has questions, please put them in the chat. And then we can always follow up with you in, you know, like when we send out the recording. So if you have questions to these brilliant, inspiring women, please drop it in the chat, and we'll try to get them answered and then sent out in the recording. Well, why don't we jump to the lightning round? Because, you know, so many, you know, having this human side to fusion, I think, is actually somewhat rare in terms of communication about fusion energy. So I think this is kind of a really wonderful opportunity for maybe each of you to just, you know, go ahead and unmute yourselves. And how do you see the potential of unlimited superabundant energy like impacting society the most? And what is one thing that you would say to somebody in high school who's maybe considering this kind of a path? Why don't we just go in order again, so that we can kind of refresh. So Joelle, do you mind?
Yeah, Paige, actually, I'm not sure to understand your question. So if you can maybe reformulate your question, please.
Oh, sure. Once we reach breakthrough with fusion energy, how is it most going to impact society? Like how is fusion energy, like what's this brilliance of fusion energy that we're all so excited about?
Yeah, I understand. So there are several manners to answer to your question. I think the first objective that we shall address is definitively to produce energy everywhere in the planet. And that, you know, that the energy is a very specific geopolitical challenge also. And in my view, it could be one of the elements to push and to bring for the peace everywhere, because as far as the populations will access to this abundant energy, that will help us, will help a lot in solving all these conflicts. Also, you know, the particularity of fusion versus fission is the fact that the fuel is an isotope of hydrogen, so is a tritium and deuterium, okay? And then, in particular, in application like ITER or demo and over fusion machine. And then I would say that particularity of this fuel is reachable by everyone in the planet. You understand? So at the end, that will open this access to the energy to everyone. It's not a case of fission, because on fission, you have to rely on uranium. This is a specific metal. There are some mines, and there is a limited quantity, I would say, of this kind of combustible fuel. Sorry. So you see, that it's one point which is extremely important. The question that we have some difficulty to address today is socio-economic impact. I mean that this kind of machine are quite expensive. Okay, the cost is still a kind of a huge difficulty in the development of fusion energy. But once that aspect will be, I would say, overcome, once we will be able to build some series of fusion power plants, this cost will be reduced significantly, definitively. But today we are not still there. So it's not only a problem, I would say, a challenge in terms of physics or in terms of fabrication. Maria was quoting the fabrication of vacuum vessel from ITER that I follow also from safety point of view. But it's really a question of how to standardize all this equipment in such a way this cost aspect will become reasonable. And the last point I wanted simply to say is the environmental impact. So we have to understand that the tritium is less, I would say, impacting in terms of health among all the radio elements because the dose factor is the lowest one. So it means that in case of release to the environment of the impact of the worker, it's quite limited as well. You understand? And there is not a long life radionuclide. So it means that on the long term, you will not have any more issue in terms of radioactive contamination, irradiation, and so on, like you could have for fission installation that will stay during thousands of years. So you see, so we have also to underline this very strong advantage from safety point of view, which are very well known since now 20 years for ITER and for other kind of installation. So that can bring in the debate.
There is certainly a whole panel to be held on those topics, Joelle, totally. Just wanted to resonate with you and, the comment about trying to address, energy poverty around the world. And, it will have an impact, fusion energy, and it will have like an impact at every level, will reshape society. It will take time, for that to be in effect. And hopefully, by deploying an alternative energy source, we can really, improve life of billions and that are right now currently have limited access to resources like clean water, healthcare, and education. So that's my pitch. Thank you so much. Sorry that I have to drop off.
Thank you so much.
Thank you.
If I can just pitch in, so because I have to leave too, I resonate with what they said, that fusion energy will really reshape the way that we live, that we produce energy, but it will take a lot of education. We need to educate people on the, on the benefits, but also the risks that it can also bring. Joelle was mentioning about tritium. This is, not in the, it is not to be confused with any of the issues we have with fission reactors, but people need to be aware that, tritium is also radioactive and all what, takes into account. So education is very important. And that's what, for instance, I've been trying to do with the class I've started here in radiation protection, focusing on fusion. But education of people, I think this should be our first goal for the next few years. And I really have to go, but it was a pleasure to hear about all these amazing journeys, and I felt very fortunate to work with in a field with so many amazing people. Thank you very much. Bye bye.
Thank you so much, Livia. Thank you. Thank you. Laura, do you want to weigh in?
I don't have to have the last word. It's okay.
Well,
unless you want me to.
Yeah. Well, Laura and Maria, both of you, I really want to hear from both of you, if you can stay on for another minute or so.
Okay, well, I mean, I think it's like Livia said, we have a obligation to everyone that have come before us to preserve the knowledge that has been created. You know, from now until the day the fusion power comes onto the grid, it might still be a little bit away. So education and just educating ourselves and educating the future generation and just keep this lineage, this continuity going, I think is our responsibility to like the past 50 years of research in fusion, right? And other than that, regarding fusion energy, I think it's just, personally, I hope the energy will actually go to the community that need it most, instead of satisfying the limitless hunger and greed. It actually goes to those in need.
Awesome. Those are beautiful sentiments of energy justice. Maria, you have the honor of wrapping this all up for us.
Can I send it back to Laura? No, I'm just joking. So, no, thank you very much. I think it's when you have a concern to do something that will help humanity, when you're looking for that challenge, fusion is definitely the place where you can work on for the rest of your life, basically, because these are very long-term projects that we're working on, right? Very long-term challenges. And it's true that we will probably spend most of our working life just doing this one thing, right? You don't usually go from fusion into something else or something that is very far off from fusion, because it's so fulfilling to know that you're just adding a little grain, a little seed to something that might in the future solve a huge problem like energy is nowadays. I mean, it impacts everything: geopolitical stability, well-being of every human on the planet. I mean, and AI and so many other things, right? So I think it's an honor to be able to work in this field, even though, as we heard today, most of us didn't end up in this field because we knew we loved fusion from age 5. You know, it's really by coincidence. But it is great to see that there's such a wonderful set of women on top of it who are dedicated to this. And I think these events like the one today help us see the human on the other side of the screen. So thank you very much.
Oh, thank you, Maria. Actually, those are beautiful words to end on. I can't top that. So thank you so much. That's exactly the sentiment. Yeah. And thank you all attendees and guests. And again, thank you Fusion Energy Week for helping us to sponsor this and organize this. It's been a wonderful insight to the human side of fusion energy. All right, everybody. That's all for now. Thank you so much. Thank you.
Thank you. Bye.
Thank you. Bye.